Wait a minute. Oh, hello. All right, folks. Welcome back to Monty's Python Show. Today we have another video in our tutorial series on object-oriented programming in Python, working with classes, creating classes, and using them in your code. Today's topic is polymorphism. Before we get started on our code along exercise, let's just take a few minutes to define what polymorphism is and why it's important. So what is polymorphism? Polymorphism is the capability of different classes to share common methods or attributes, facilitating versatile and reusable code. The behavior of a method may change depending on which class is invoking it. So change is the key word here. Morphism. Morph means to change. Poly means many. So what polymorphism is in Python is the ability for methods to change their behavior depending on which classes are invoking them. So why is this helpful? Polymorphism allows the same method or function to be used within different types of objects, which promotes code reuse. And hopefully today's code along exercise will make that apparent. It enhances code clarity by enabling the use of generic interfaces, making it easier to understand and maintain. It's going to clean up your code because you will only have to define certain methods one time within classes, and then you can access that same method from other classes that inherit it. So let's go ahead and get started. This is actually the code that we're going to write today, but I just want to go through it real quick and point out a few key aspects. First, you can see that we are we have defined three different classes: shape, circle, square, and we've created two objects, C and S, which are instances of the circle and square class respectively. Now we've invoked the area method here and here, but you can see in the code that the circle and square classes do not actually have an area method defined within them. The area method is defined inside of the shape class. So when we invoke the area method, the classes search first inside themselves and then up to the shape class where they will find the area method. And that works because the circle and square methods have inherited the shape class. Now you notice what the area method does is it simply accesses a class attribute and a method from each of the from any class that would call this method. So it's written as a very generic method or generic function. And this is beneficial because if we're going to use this area function and we want to change it to be something different, then we only need to change it in one place. We wouldn't have to go in and change this method for every class that had it defined if we didn't define it at the parent class level and use polymorphism to access it. Okay, so now that we've defined polymorphism and reviewed what it is and why it's important, let's go ahead and put it to use in our code so it will become more clear why it's beneficial. So I'm actually going to be programming today in Jupyter Lab. So this is a Jupyter Lab screen. I'm accessing it through the anaconda.cloud, which if you haven't checked that out, I would highly recommend creating an account for yourself at anaconda.cloud. It's a really useful service. It gives you access to Jupyter Lab online, and you can create a free account and get, I believe it's 5 gigabytes of cloud storage, which is for notebook files. There's actually quite a bit of storage online. You can store many Python files, and it makes it very easy to share files with others. You can embed your links to your files into websites and things like that. So it makes it really easy to share. And Jupyter Lab is a really great development environment for learning because it allows you to type separate blocks of code in code cells and see what that code does, and then you can string many code cells together. So it's a great format for learning Python. So let's go ahead and start typing our code, working on our code today. So polymorphism is the theme, and we're going to write a quick program where we're going to create 3 different classes. So we're going to start first. First thing we need to do is actually need to import from math. Let's import the py function from the math module because we're going to use that in one of our classes. Now we're going to create our first class called shape, and shape is going to be our parent class. Remember to use Pascal case when naming your classes. And I'm just going to give it a generic class attribute here called type. and call it general. And now I'm going to define a method inside of my shape class called area. And area has no arguments aside from the self argument, which we'll always put inside of methods that we define in our classes. And our area function is going to do something very simple, but we're just going to put pass in there for now. And this will become a little more obvious what it's going to do here in a few seconds. Okay, so there's our shape class, our parent class. Now let's create two child classes, one for circle and one for square. So class circle, and circle is going to inherit from the shape class. So we're going to put shape inside of our parentheses. It's also going to have its own class attribute called type, and that's going to say circle. And let's define the constructor method, def double underscore init double underscore self. And the circle method will have one parameter, which is radius. And you can probably see where we're going with these functions. Okay, so inside of our constructor method, we need to go ahead and save that radius attribute as an instance attribute, self.radius equals radius. So that's it for our constructor method. Now let's create our method to calculate the area of a circle. So we're going to call this underscore calc area. So with the underscore preceding calc area, we are signaling to developers and other users of our program that the calc area method is only meant to be used inside of our classes and is not meant to be accessed outside of the class. We didn't use double underscore because that involves name mangling and it just makes the writing the classes a little more difficult and confusing. So we're just going to use a single underscore. So this method technically will be accessible from an instance, but hopefully the single underscore will let people know that it's not intended to be used that way. So this function is going to return the area of a circle. So we're going to return pi times radius squared. Okay, so pi radius squared, that is the area of a circle, and we're just simply returning that. Now let's create our square class. Again, square is inheriting from the shape class, so make sure you have shape inside of parentheses. Just give it the class attribute type, set it equal to square. Define the constructor method. And a square has a single parameter that will be entered, which is the side, the length of any side. And we need to go ahead and define our instance attribute side, self.side. We'll set it equal to the value that the user passes in when they create the object. Self.side equals side. Okay, that's it for the constructor. Now let's define our calc area. Def underscore calc area self. And this will return self.side squared. Okay. So we've got our three classes defined. Now let's go ahead and create objects of those types. So we're going to create a circle, C, an instance of the circle class. We're going to pass the argument 3 to it. So that is going to be the radius. Remember, we defined one parameter in the constructor method for circle. So that is our radius. And let's create a square, S, an instance of the square class, with length side 3. Okay, so we've got our object set up, and we need to go back up here into our shape class and go ahead and create our area method that we're going to use. And I'm just noticing there is an error right here. In our circle class, I made a mistake here. the calc area method inside of the circle class, this should say pi times self dot radius squared. I just had radius there. So radius, you might wonder, well, why wouldn't that work? Radius is here, but that is local inside of this init method. We can't access it here in the calc area method, so we need to use self.radius there. Okay, so we've got that fixed. So let's go back up to our shape class, and let's go ahead and define the area method. And there will be no parameters passed to it other than self. And the area method is simply going to return, and then it's going to call the underscore calc area method from whichever subclass that called it. So it's going to return self dot underscore calc area, no argument. Okay, let's go ahead and run this and make sure we have no error. Okay, good. So everything seems to be okay. So now in this code cell down here, let's go ahead and print c.area and s.area. Run that. Okay, so we got two values. We got 28.27 for the area of the circle, and we got 9 for the area of the square, and those are good, the correct answers. So the code works well. So what's going on here? Well, when we are calling the area method invoking the area method for these two different objects, it of course first searches inside of its own object class to see if the area method exists there, but it doesn't. But it inherits it from the shape class. So it runs the method, the area method, from the shape class. But in each case, depending on if it's being invoked for the circle or the square and square actually change how this method is working through passing its own self information. And even though the method doesn't exist in that class, when it calls the method from the parent class, it acts as if this method was written inside of those subclasses. And so that is how the method changes its behavior depending on which class is invoking the method. That is the polymorphism. And so why is that useful? Well, in this particular case, why couldn't we have just called the underscore calc area functions here? Well, we could have. But what if we wanted to have a general a general function that calculated area and did more things? Well, it becomes a lot easier to manage if you can control that method in one place rather than changing it in multiple places. So for example, suppose instead of just returning the actual value, we wanted to change so that it returned a formatted string that told us both what the type of the shape was and what the area was, and then formatted that number. Well, if we wanted to do that, we would have to change both of these two methods' return values to have this information inside of a formatted string, right? So we would have to write code in two separate places. The way we've written our code here, taking advantage of polymorphism, is we only need to do that here. Let's just create a string up at the parent class here in shape, and let's say the area of the self.type is self.calc area, and then let's format it for 2 decimal places floating. Okay, so I've changed how the function works, but I've only had to change that code in one place rather than 2 different places. So let's run that code, and now we run this. Okay, and we see we've got 2 different formatted outputs. The area of the circle is 28.27 and the area of the square is 9. So the polymorphism, again, it knew which type and which function to call based on which subclass was calling it. And we only had to write 1 line of code to make that change rather than write 2 lines of code. So you can imagine if you had many different shapes defined as subclasses, how much time and energy you would save by just defining and running that function here at the parent class level and taking advantage of polymorphism. Okay, that does it for today's video on polymorphism. Hopefully that was helpful and you better understand how to use polymorphism in your code now. In our next video, we're going to be exploring the concept of method resolution order and discussing the diamond problem in programming. Thanks for tuning in to Monty's Python Show, and we'll see you next time.